Hello, everybody. Welcome to our first CTO Brown Bag session. And today with us is Yoni. And we also very lucky to have Santona with us as well. Yoni and Santona, would you take a second to introduce yourself?
Yep. Hi, everyone. I'm Yoni. I'm the CTO of Upsolver.
Hi, everyone. I'm Santona. I work as a product manager at Upsolver.
All right. Well, great to have you too. So today we're going to have a really fun topic to talk about. So I think, data workload or workflow orchestration has been around for a long time during the older days of things. When we work with on-prem traditional data warehouses, I think all of us may have written our share of shell scripts and cron jobs and things like that to orchestrate a lot of the workloads. And I just want to ask Yoni some of these some questions, what he thought about how we used to do things, how we currently do things, and what he sees the future of data workload orchestration. So Yoni, go ahead and take away and let us know how you used to do things and what are some of the pros and cons of the traditional data workloads. Yeah.
So yeah, first of all, it's important to note that orchestration, it sounds like not a big problem. But in reality, if you look at what data engineers do in their day-to-day, the fun part is when they get to write cool SQL queries and build scripts that pull data from here and write data to there and do interesting things with that data. And the not fun part is everything around it that deals with making sure that this will actually work in production all the time. And it's like 80-20. So data engineers are, they're sold on, I'm going to be doing cool stuff with data. And in reality, they're debugging a pipe that's leaky and breaking sometimes and trying to figure out kind of what went wrong. So I think that's it's very important to frame the problem that in fact, whereas orchestration is the kind of part that's not that interesting from a data engineer's perspective, it is the area where they spend a huge amount of their time. And a lot of their bugs and issues and problems come from the orchestration realm. Is it data that got lost, data that got duplicated, all these things. So I think that's very important framing of the conversation, that this is a huge problem that's taking up a lot of people's time and a lot of attention from an organization.
Yeah, and I think traditionally we have a lot of problems in the past that we are still seeing today, which is if you can test it all you want in dev, once you introduce your code into prod, it breaks a bunch of different things, right? In the past, I think it's very rigid how we work with orchestration. And would you just talk a little bit about in the past how you solve these problems? So when you have these leaky problems, data quality issues, how did we solve these issues in the traditional way with Teradata, Oracle, DB2, Informatica, App Initio, all of the traditional tools on-prem? How did we used to do that?
Yeah, so I mean, the way that you deal with an ETL problem, so you have data that's residing somewhere, and I have a query that I want to run on it in order to pull it from here, send it there. And I want that to happen every few minutes. So I have an Airflow DAG, which is super simple, and it's every few minutes, run this query, pull data from here, send it there. So that's kind of the very basic start of your orchestration nightmare, is that you have this simple DAG that's just saying, I want to do what I declaratively am trying to accomplish. And then complexity starts. So I have a process where this thing is running for a bit, and then it fails because the same query ran twice at the same time. So now I have to update my DAG to make sure that it can't run in parallel to itself. But maybe sometimes it gets delayed. So now I have to update my DAG so that if there's a delay, it'll run a bigger query, maybe a different query that knows how to handle a larger amount of data so that the query won't time out and create a backlog. But maybe my database has maintenance windows, and then the DAG can't run. So now I need to correct the DAG so that if it can't run, maybe it needs to correct the timestamps that it's reading from, and et cetera, et cetera. So, I mean, basically, you have this super simple DAG that a lot of complexity gets added to it that's not related to the problem you're trying to solve, but related to the technical features of the world around it. So you just have these, images on the internet that you can find of giant DAGs that, I mean, really the interesting part is a super small part in the middle, which is what you're actually trying to accomplish. And all the rest is error handling and exception handling, essentially. So I think that's like, that's the world, essentially, is like, that's what people are doing, is a lot of exception handling around how data is flowing from A to B.
Mhm. Yeah, so like a DAG is designed to only go one direction, never go back. Like that's the purpose of a DAG. But if you want to roll back, and a lot of times we do want to roll back because of user errors, data quality issues downstream, like how do you roll back something when it's in the DAG?
So, I mean, yeah, that's a super complicated question, and the answer is always it depends. So, I mean, you can always say, well, okay, this DAG ran on these times. Now I want to run it again on that time. But
Mhm.
I mean, this DAG is going to have all sorts of side effects and all sorts of exception handling, which may or may not be valid, given the state that these tasks already ran. So not everything is designed to be idempotent. So an idempotent process is a process that I can apply multiple times, and it's not going to change anything after the first time that I applied it. And that's like, it makes reasoning about your transformation super simple, because I can just try again and again, and I don't need to worry about what happens if I accidentally succeeded twice, or if I want to roll back and do it again after a long time. I don't need to think about that. Like, it makes reasoning about your process a lot easier if everything you're doing is idempotent. But it's super hard to make everything idempotent. You have to like really specifically handle this in every single edge case that you're dealing with. So in most cases, that's not the case. And then you have to think about, well, okay, I have this ETL that transforms these rows. And if I replay something from a month ago, I'm going to transform the rows back to the state they were, and I will have no way to then recover the additional changes I had. Is that okay? Am I willing to suffer that data quality issue? Or do I rather just not do this and give up on the data that I'm missing? Or all sorts of like, so it very much depends on the exact specifics of what's in your DAG. That can you roll back? How much can you roll back? When you're rolling back, what are going to be the I mean, technically you can just replay it. That's pretty easy. But like, if your DAG is incorrect for that use case, then it's not going to work, or it's going to give you unexpected results.
Yeah, especially if data is truncated, when every time you run the DAG, like a historical data get truncated, then you cannot really replay that data anymore because you don't have it. And then you result in people trying to do these one-shot fixes downstream, and then you end up with a huge like data integrity issues that you can't fix, right? Like that's a kind of
Yeah, and this is definitely a snowball effect. Like, there are often situations where you have a process that's running and everything's running smoothly. You just want to like, okay, there are a few events that you missed, so rerun this little part. But all the data was already deleted except for those few events, so now you rerun it and you overwrite a healthy chunk with an unhealthy chunk that now you've deleted it. You can't go back. Like, it can very easily turn into a nightmare of like, weeks or months of work trying to recover from some catastrophic error that just happened because you didn't think through. I mean, it's super hard to think through all the edge cases around data. And that's why, I mean, idempotency is so important in that regard, because if you have that guarantee, and again, it's super hard to guarantee that, but if you have that guarantee, then if you apply the same transformation, you're just going to get the same result. So there's no such thing as my data is missing, or there's no, like, you can't run the same process again if it's not going to guarantee the same result. That's kind of what the idempotency does. So, I mean, easier said than done, but if you have that, then replays become a lot easier.
Yeah, that makes sense. And do you see like traditional data warehouse way of doing things, on-prem versus the cloud? Do you see people are doing any changes when they move to the cloud, or do you still see like a traditional way of doing things in the cloud as well?
So, I mean, I think that there is a lot more flexibility in the cloud. So the place where you see things changing is around it is around how much compute resources you can apply to a certain problem. So usually you have, like, on-prem, you have 100 servers, and that's what you have. And if you want to process a much larger amount of data, you're kind of like out of luck. Like, this is the amount of servers you have, and it's not elastic in the sense that you can't suddenly provision a lot more. So in that sense, in the cloud, you have a lot more flexibility around how much processing you're doing. And often like these one-time ad hoc things that you want to do require a lot more compute resources for a short amount of time. And then you're done and you go back to your steady state. So the cloud is super convenient for that. Like you can easily spin up another 1,000 servers, which then you can release after an hour when you're done your work. So you see like both replays happening a lot more frequently because it's possible, because you have the compute resources to do it if you need it, and also completing much faster because you can scale up a lot. And you have a lot of things like, like Kubernetes clusters and things like that are trying to give you that value in on-prem, but still, like, you have the hardware limitations that aren't flexible. So definitely when moving to the cloud, you get that kind of compute flexibility. Also storage, by the way. So on-prem, traditionally, storage is expensive and it's finite. So you have to think about how much storage you're going to be consuming. In the cloud, it's relatively cheap and it's effectively infinite. And the effectively part is really more related to billing. So your finance guy is going to say, hey, you're storing too much data and this is costing me too much money. But that always happens after. So then people tend to store a lot more data, a lot more intermediate states in the cloud. So that, again, makes it more likely that you're going to have the data that you need. Whereas in on-prem, like, you could have ridiculously short retention cycles that then very quickly you're in a state where you just can't recover anyways. So I think the cloud made a lot of changes in that, but in the actual, like, what commands I run, it ends up being quite similar. So there isn't a very big shift as far as how you're actually doing the recovery. So that's still terrible. But you have a lot more resources at your disposal so that more recoveries can, let's say there's more demand for recoveries because it's possible, but it's still hard to do.
Mm-hmm. Yeah. And that brings me to the next question. It seems like then the cloud is more of a data lake architecture versus the traditional data warehouse architecture, where data lake architecture is even more complicated when it comes to orchestration, because there's a lot more variety that's in the data lake. Would that be a correct assumption?
Yeah, I mean, definitely people, I mean, there are some organizations that are building data lakes on-prem. So it's not that it doesn't exist, but definitely data lake as a concept is very cloud. Like traditionally when people think about a data lake, they're thinking about S3 or blob storage or something like that. And data lakes do add a layer of complexity that normally, like when you're dealing with a monolith that all your data is in a single database, at least you know how to access it. I mean, at least you have all the tools are at your disposal. Whereas in a data lake, data can often just get lost. Like, it's kind of like not indexed. It's not easily discoverable. So if you didn't like write the data a priori with the use case in mind, you can often, like, the data technically exists and it's even kind of like very compelling to think, well, I have all my history there. So when something bad happens, I'll be able to just, run my replay. But I mean, is it in a format where I can access it? Are the files in a way that I can even find them? Like it could be that the data is there and costing me money, but I'm not actually going to be able to get value out of it in retrospect. And building a data lake is an art. It's not like, there aren't, obviously, being the CTO of Upsolver, I'm biased, but there aren't many companies that give you, here, this is a ready-made data lake that gives you all the features. You kind of need to build it yourself. And depending on who built it, when, do they still work at the company, it might be valuable and it might not be valuable at all.
Yeah. And I think that's kind of like a lot of the current state of where the orchestration is today, right? Like your data lake and people trying to orchestrate the data workload from object store into maybe a target, and using tools, various different tools that are out there. So what do you think the future of the orchestration? So like, so far we've been talking about the traditional way of doing things, which is a very manual. And it seems like today, even with DAG architecture, is very manual as well. In case something does happen, or they need to, if people need to introduce a new business question or business need into the architecture, they need to manually go in and adjust a lot of these things. So what do you see the future of what's the ideal way of building an orchestration in your opinion? Yeah.
So the way I see it, and also Upsolver's philosophy, is that orchestration isn't actually a thing that you should be thinking about at all. I mean, in the end, you can think about it like a trigger in a database or a materialized view in a database. These are services. I mean, a trigger, to people who don't know, is just like a record enters a table and you get an event and you can respond to that event, maybe add a new record to the table or things like that. Materialized view is simply a query on top of a table, and the database makes sure that the materialized part that is in fact represents what the query says. So this is completely encapsulated by the database. You're not aware of any kind of orchestration logic that goes into making sure that the trigger actually triggers. And there isn't such a case where you say, well, maybe the trigger didn't trigger, so I need some error handling. No, the database takes care of it. It'll just trigger. The database guarantees to trigger the trigger, and the database guarantees that the materialized view, in fact, does what it says on the cover. So in that sense, you're just not orchestrating. It's abstracted away from you. Of course, the database itself is doing a lot of heavy lifting to make sure that everything works as it should. But the user isn't aware of it at all. And I think that in the lake, that's the same concept that you should have, just with a lot more power, because you have all the history and you have all the replay capabilities, and you can do transformations that are idempotent because you have the place to store the original states. But still, the high level guarantees should be there. So you're not thinking about orchestration anymore. You're just saying, well, this is the transformation. This table should turn into this table. These rows should go to these rows, and that's it. And the underlying system should take care of what happens if fill in the blank, and just give you a strong guarantee this will in fact happen at the end of the day. And you can just work on your actual ETL logic.
Yeah, and I think that's the way. That's what, when we say it's declarative, that's the way it's supposed to be. And the way I was kind of explaining and trying to talk about this with Santona, and because she comes from a very traditional DAG world of things, is basically I use the analogy of a temperature control. It's like you set a certain temperature, and it's smart enough to bring you to that temperature without you having to interfering with it. Whereas if it's more imperative way of doing things, you can always have to change the temperature depending on what your needs. So it's a lot more manual process in the imperative way of doing things. So Shannon, like you come from a very traditional way, like a more traditional way of orchestration. What Yoni had described, does it resonate with what you're seeing as well, or?
Yeah, very much so. I always say like the right amount of abstraction is really hard to find, but when you do find it, it's like game changer. And I think that with this technology, we do have the potential to be that, because yes, Yoni, you're absolutely right. As a data scientist or a data engineer, or an analytics engineer or a machine learning engineer, what I want to focus on is my use case and bringing value to my end users through the data transformations that I'm doing, through the models that I'm building. So I don't necessarily want to be thinking about orchestrating my pipeline, or if I'm building a user-facing app, I don't want to necessarily spend a lot of my time on operationalization. So just being able to sort of offload that to a reliable tool or a service, I think that, yeah, that's a huge deal.
Yeah, it's also not even what you're being measured on. So like, people ask you as a data analyst for a dashboard, and like, you're being measured on actually delivering the dashboard. If it breaks later, they're just going to be angry at you. They're not like, they don't care that there's a lot of complexity happening behind it. So it's really like, letting you focus on the things that people care about, both like the people that you report to, but also like what you find interesting, because like this is the job that you decided to do. I think it's super valuable, like returning the time to the analysts and the scientists and all these people.
Yeah, absolutely. Like starting from gathering those requirements to creating the dashboard, if you go the DAG way, it takes a lot of time, right? So you sort of constantly have to push the brakes and say, okay, this is, I can do the proof of concept, but now I have to go and take this work and DAGify it and then, operationalize it. So, you have to wait. So that's part of it. And then, as you said, even after I've delivered the dashboard, anytime it goes down, the debugging involves going back into that DAG and sort of really working through it all. Whereas with a guaranteed, as you described, the database guarantees the freshness of the data and the data triggers. I don't have to think about any of that.
Yeah, and I do believe this is a direction, whether it's infrastructure, if you look at like Terraform, CloudFormation, Kubernetes, whatever it is, this is where microservice comes in for infrastructure, is the declarative way of trying to do things. And people shouldn't have to worry about how things are deployed. They don't care about how the containers are deployed and being managed. They just need to do their development, and then everything gets deployed for them automatically. And I think that's going to translate into the data world's orchestration as well. It's like Yoni said, it's like, this is the future of orchestration. Is basically very similar to microservices. You define what it's supposed to be, and you shouldn't have to worry about the details of ins and outs of how we get you there in the back end, basically. Yeah. So.
Yeah, and you said something very important before, that like you need to get to the right level of abstraction. I mean, if you abstract too much, then you just can't fulfill your use case. And if you don't abstract enough, then you get bogged down in details of things that you're not even necessarily knowing how to solve well. So it's kind of like, counterproductive. Like you have to be kind of exactly at that level where it's powerful enough. It gives you enough flexibility that you can, in plain English, tell the system, I want this to happen after that, regardless what happens in between. And then at the same time, it should be still high level enough that you don't need to go down beyond the plain English explanation. That's enough. I mean, that's how we think, and that's kind of really how you want to be communicating it. And getting to that kind of that level of abstraction is I think that's where the art is, and that's where you're going to find the differences. Because I mean, everyone's going in this direction eventually, but some might choose a route where you have something that's fully orchestrated but not useful, or something is completely useful but takes infinite amount of time to maintain and build. And finding that line in the middle, where you're on the one hand super useful and on the other hand not complicated, is, I think that's where different tools are going to differentiate. And I think where Upsolver did a very, very good job of going exactly to that place where it's useful.
Yeah, awesome. Yeah. So Santona, do you have any more questions for Yoni, or?
No, not at this moment.
Yeah, I think our 30 minutes is about up, and I just want to say this has been a really fun session to have a brainstorm session with Yoni on the future of data workflow orchestration. I think it was very informative, and I hope everybody enjoyed the session. Yeah, thank you, Yoni. Thank you, Santona. Now I'll see you in our next session.
Thank you very much.
Thank you. Bye.
Bye.